this is a quick video on how to draw Lewis structures from the molecular formula. So I'd like to do one that's a little different. This would be N2O, and many students want to put oxygen in the middle, but remember there's some steps we want to work through to solve for the Lewis structure for a molecular formula. It's really important that you have a process. So the first one was just to find the valence electrons. How many do I have within this structure? So again, we took the number of valence electrons and determined that by looking at how far to the right does it sit in the periodic table. We can count over to nitrogen, which was 5. We can say, well, there's 2 of them, so we'll say 5 times 2. And we're going to add to that, if we step over 1, 2, 3, 4, 5, 6 is what you have as number of steps getting to oxygen. So we can say safely that there are 16 electrons that are in the bonding for this N2O. So now we move on to the second step, is building a frame. This is where, again, some students would be tempted to put oxygen in the middle. But remember, the rule is who has the greatest need of bonding, so most codependent, we said. Or you can also see sometimes people will say least electronegative. It's the same thing. To say least electronegative, which is just desirous of electrons, it's the same thing. So greatest need, least electronegative, it's the same. So we can go ahead and look at N and oxygen, and we know when we look at N, it's to the left of oxygen, so he's further this way than oxygen. So the frame would look like this. It looks odd, you might think, but it's the best we can do, is to put these 3 together where one of the ends is in the middle. We can't have both of them in the middle, but we can have one of them in the middle. Alright, so now we know there are 16 electrons that have to go into this frame that we've build the frame. And we notice, though, that there are already 4 electrons. And you say, well, how did you notice that? Well, because every line is a handshake, and we know 2 hands are in a normal handshake, and so you'd say 2 electrons, that's 4. 4 from 16 is 12, so we need to have 12 more. So we need 12 more electrons to go into the third stage, which was add in your lone pair electrons, just kind of pairing them up. We don't want to have what we call radicals. Add in lone pairs from outside to inside. So I'm going to go ahead and use this space, because I know I need 12 more. I'm going to go ahead and use this space over here. And we'd say, okay, I'm going to start, doesn't really matter too much, but I'll start on the oxygen because he is more electronegative. He's more desirous of electrons. So you guys remember in class 2, 4, 6, 8. Who do we appreciate that? We stop there and say, okay, well, that just got me 6 more. So I can do the same thing over here. 6 more, and 6 plus 6 is the 12 I need. So just to count to make sure that I have all of the electrons that I need into the frame, and then you can just really focus all your modifications to this. No more dots are needing to be drawn, and any lines can be made from the dots. It's really important. It kind of gives you a focal point. This is our frame with lone pairs added in. 2, 4, 6, 8, 10, 12, 14, 16. So this is good. We're on our way. This is our frame with everything added in, but we of course need to consider how can we satisfy this nitrogen. Well, we can do it one of 2 ways. And you remember in class we started talking about how we can have those lone pairs drop down in different ways. So I kind of use dash and then maybe use a blue color for a different way. So I'll have this one be our kind of a red option. We can have these electrons come down, because you say, well, why are they coming down? Well, these have 8 around them, this has 8 around them, but this only has 4 electrons around them. So these have 2 kind of drop downs. So our last thing down here was drop, I guess, down if needed. Drop down lone pairs to make double bonds if needed. And we do need to. So we're seeing, hey, I need to make at least 2 more electrons come down towards the nitrogen. So I'm just going to go ahead and do it twice from the same side. If we did that, then we would have the following: in having now 3 bonds to oxygen, not just 1, and this nitrogen would still have all those lone pairs over there. That's one way, but we could also come at it from the nitrogen. Now, we don't want to have the nitrogen give, I guess, all of them. We can do that, I guess, as an alternative and see which one's more stable. It might be a mix of both, so I'm going to kind of put this one over to the left while the next one in the middle, so the nitrogen can give all its 2 lone pairs, and give 1 from the bottom, 1 from the top, we'll say. And we would have the following. Now, we said in class of these 2 structures, this one's actually a little more favored because the oxygen has 1 more bond than what it wants here. It has 3 bonds. Nitrogen likes to have 3 bonds. This one does not. But we have one more way in which we could satisfy. We could have 1 come from the nitrogen down to the nitrogen and 1 come from the oxygen. So I'm going to draw all 3 resonance forms. And remember, we talked about resonance forms are just a mix. What does this really look like? Or what does N2O really look like? It's a mixture of all 3. And let's put the formal charges in and we'll be done. So this would probably be least contributing, but its charge we would have a -2 over on this nitrogen because he has 2 less bonds than what he wants. This nitrogen in the middle has 1 more bond than what he wants, so he would be positive. And this oxygen would have 1 more bond than what he wants. So you can kind of see we got a lot of charge there. That's why this is kind of unhappy. This is happy. This would be positive, and this would be negative. So that's looking better as a contributor. So this might be a lot more contributing than this one. But here we probably have a little bit of both. So this has a positive charge, and this has a negative charge. So these 2 right here on the right side would probably be the 2 resonance forms that I need to draw because they have just a positive and a negative. He has just a positive and a negative, but this has 2 positive charges and a -2 charge, which is just not very likely. Hey, that's the process. Remember, you need to remember how to determine valence electrons, know how to build a frame, add your lone pairs in, and drop down if needed to make those double bonds. And then you're good to go. Peanut. Thanks.